All right, you guys, making our video for topic 7.4. This is the transformations day where we move parabolas up, down, left, right, vertically stretch and compress them. Most of this could be answered in Desmos if you wanted to spend the time typing it in, but almost all of this should just be logic based if you know your transformation rules. Okay, so our first one says which graph can be obtained by translating the graph of h of x equals 0.33x squared plus 2 down 7 units. Okay, so we're taking this graph. I'm gonna rewrite it, and you'll see why in a second. Now, I don't even care what this graph looks like. All I know is they have asked me to move it down 7, right? And if you remember anything about transformations, that is a vertical movement, which just means that you are going to either add or subtract that number from the end of the function. So down 7 would mean I would just be literally subtracting 7 off of this function. Now, what I can clearly see right here is he already had a starting intercept of positive 2, all right? Because when it's written in standard form, the c value is the y-intercept, right? But I'm subtracting 7 from that. So if I actually do the math, if I know he started at positive 2, here, let me just draw all of these. This is where our parabola started, right? It started with a y-intercept of positive 2, right? That's what it's saying. But then we moved it down 7. And so, of course, that means he should now have a y-intercept of negative 5. And there's only one graph that has a y-intercept of negative 5, and that would be C. If you want to type it in Desmos, you're more than welcome to. But again, it's just a lot quicker and easier just to understand it and do it logically in your head. All right. And of course, these are, please don't miss the multiple choice questions, right? The multiple choice questions, out of all the questions on the test, those should be the gimmies, right? Because they don't require a ton of work. You could put them in Desmos if you want to, and we're literally just matching up the graph, okay? All right, number 18 says which graph of the quadratic parent function, all right, I'm going to stop right there. So remember, the quadratic parent function is, and I'm going to write this as f of x just in case you want to put it in Desmos. So you are more than welcome to write f of x equals x squared and type that in Desmos. And the reason why I'm using f of x is because they're clearly using f of x in the transformed function, right? They're calling the new one g of x, but it's based on f of x. So that's why I want to make sure I call the parent function f of x. Was formed to create the graph of g of x, which graph best represents g, the new function. Okay, so we just need to use our knowledge, right, to remember what does it mean when we have a plus 2 inside the parentheses. Well, it's clearly a horizontal movement because it's trapped inside with the x, and it's always the opposite of what you think is going on inside those parentheses. So this is actually left 2. And then we have the minus 5 hanging off the end, and we just had this discussion, right? So whenever you put a minus 5, that's a vertical movement, and that means we're going down 5. And those are the only two things that have happened to the parent quadratic function. Left 2, down 5. Now let's recall just really quick. 2, 4. Right, these are the initial points of the parent quadratic function. So here's what he looks like. Whoops. All right, and I'm just drawing it on this graph just so we have a visual. Right, so there's our parent linear function. I want the one that's been moved left 2, down 5. Well, it's clearly not A because he got moved left 2, up 5. It's not B because he got moved right 2, down 5. C, oh, it looks like C was left 2, down 5, and that is what I'm looking for. And then it's clearly not D, who's been moved right 2, up 5, right? So they've done every possible direction there, right? But the one we wanted was the left 2, down 5, so that is C. Again, if you wanted to, you could type in this into Desmos and then all of this verbatim into Desmos, right? And you could then match up the graphs, right? But that's pretty time consuming. All right, hopping over here, it says list all the parent functions that are happening to the parent quadratic function. All right, so we're just going to go through this list. I think this takes care of topic number 4, so it's going to be a short video. All right, so on A, a lot of people look at A initially and they think there's only 2 transformations, but that is not true, right? Because in the world of transformations, this negative alone tells me something, right? And then the positive 3 tells me something. And then the +4 on the end tells me something. So this is actually 3 different transformations happening to our graph. So of course the negative in the front is a reflection over the x-axis, which we should all know because that's how we know that a parabola opens downward, right? And what makes a parabola open downward? A negative in the front, because that's a reflection over the x-axis, right? So that should be an automatic. The 3 in the front, so remember the 3 means that you're stretching it 3 times taller, right? You're grabbing those arrows, right? And you're pulling them up or down in this case. So this would be a vertical stretch by a factor of 3. You could just write vertical stretch, that's fine. But more specifically, I would like to know, again, just like we did in class, if I vertically stretch a parabola, right? If I take a parabola, this one opens down, of course. If I take a parabola and I pull it even further, right, 3 times lower, right, then is it going to get narrower or wider, right? And anytime I do a vertical stretch, it's going to make my parabola narrower because anything that gets stretched out gets skinnier. And then, of course, that +4 at the end is a vertical movement of up 4. All right, next one. Looks like we have this -8. That's the only thing that's going on. We already chatted about this, right? Anything trapped inside the x is a horizontal transformation, and it's the opposite of what you would think. So in this case, that means we're being shifted right 8. All right, letter C is the one that has the most. Again, we just chatted about this. You got the negative in the front, means something. We've got the 1/2. That means something. We've got the +3 inside the parentheses, right? And then we have the +4 on the end. All right, so I'm just going to run through these really quick. We've already talked about the negative multiplier in the front, right? This is a reflect over the x-axis. Now the 1/2 means I'm smashing it down half its normal height. So this is going to be a vertical compression. And of course, anytime I smash something down, it has nowhere to go except out. So this is actually going to make my parabola wider. And then left 3 and up 4. Okay. 2 left here. All right, so this one's got 2 transformations, and it looks like they're all vertical transformations because nothing is trapped inside with the x there. So all of these are happening vertically to my graph. Obviously, the -3 on the end means down 3. Now, this 5/4, right, you want to be careful. He is a fraction, but he is a fraction greater than 1, right? 5/4, right, is going to give us 1.25. So that means this is a vertical stretch, which of course makes our parabola narrower. All right, and then lastly, this guy only has a +5 hanging out inside the parentheses, right? So this is just left 5. And remember, these are all based on our parent quadratic function. Ooh, I thought that was our last one. It was not. We've got another one that has 4, right? We've got the negative, we've got the 7, right? Then we have the -3, and then we have that -9. All right, well, we've already talked about every single one of these already, so I'm just going to kind of fill them in. The negative multiplier in the front is a reflection over the x-axis. Then we've got that 7 multiplier in the front. That means we're stretching it, right? 7 times taller, in essence, right? Even though it's going up forever and ever, right? We're taking those arrows, right? And we're pulling them up, which is going to make him narrower, right? So this is a vertical stretch. Narrower. Then we have our -3. It's inside, which actually means right 3. And then we have our down 9. All right, that was all of them. And then our next topic is 7-5, right? So I'll come back and do another video for that guy.